This is Katrina. Oh, we're live. Hello, this is Katrina with ETH Miami, and we're on the road to ETH Miami, which is October 27th through the 29th in Miami. And I'm here with Kevin with Edge and Node, and he's going to tell us about the graph.
Thank you so much, Katrina. I really appreciate it. Yeah, thank you guys. Just a quick introduction. Yeah, I'm Kevin from Edge and Node. I'm working on the graph, which is an awesome protocol that everyone should be made aware of because it's very critical to Web3 and the future of decentralized data. So if I just could go ahead and present, that would be great.
Great.
And I'll do my entire screen here. All right. So hopefully everyone can see my screen.
That's I see. Yeah, here we go.
Yeah, you can see everything. Okay, awesome. Cool. So I'm going to talk for probably 20 minutes or so, and then I'm actually going to do kind of like a live demo where we're actually going to build a subgraph and deploy a smart contract. So real quickly, again, my title is Developer Relations Engineer at Edge and Node, working on the graph, and I'm coming to you live from San Francisco at the House of Web3. If you guys are in the San Francisco area ever and you're building in Web3, I would highly recommend you guys come check it out. It's a really cool community. It has a shared working space and they have events here all the time. So I'd highly recommend you come check it out. So we're going to start with like the basics, and kind of just try to build up to like why the graph is an important part of the ecosystem. And it all comes down to like, what is a smart contract? And really, like, if we look at like some kind of example here, which we're looking at like CryptoPunks, really the data storage for the actual NFT contract is, what is stored on the blockchain, right? So you have these kind of unique NFT IDs, they have an owner, and then they have an associated metadata URI. So it's just this kind of like table of information. It's kind of like a database, right? It's a distributed database. And one thing that is great about the blockchain is you can read data, but what about provenance? Like, how do you get the historical data for the blockchain, and how do you get like large amounts of data at the same time? And this is kind of like an example of where the graph comes in, because the graph can actually store historical information about the graph, and you can think of it kind of like a time machine, where you can actually go back in time and get, like, let's say you wanted to know who owned a specific CryptoPunk at a certain date and time. That would be very difficult to do. You would have to parse through the entire blockchain and get the entire history, or find out, when that NFT actually changed hands. And so this is where the power of the graph comes in. We look at like a standard transaction on the blockchain. A transaction is just a message, right? You're sending a transaction to the blockchain and you're trying to like write some information. And that's really what Ethereum or most blockchains are really optimized to do. They have these kind of security incentives that allow security to keep the consensus up and for people to write and sign transactions against the blockchain. But there is one problem with the blockchain, and that comes to like these kind of initial dApp architecture. If we look at it, was something like this, where users would, build their user interface in something like React or Next.js or some kind of JavaScript framework, and then they would use plugins or some kind of SDK to be able to communicate with the blockchain. And they would do these kind of like read and writes. And this is a very simple and optimized way to write something, because you don't need to write a backend. You can write all of your code in your smart contract, and then your user interface you can design however you want and kind of sit into that dApp architecture. But the problem is that reading data, again, is very difficult on the blockchain. There's really not a huge incentive. Most of the security and the mechanisms in place for a blockchain are really incentivized for securing the network in terms of writing transactions. And when you want to read a lot of information from the blockchain, or you want to go back in time and see historical information, it's very difficult to do. And so this is where the graph comes in. And what we end up with is something like this. If like a developer, this is actually like real-time code that was running where someone was wanting to get all of the IDs of a specific or NFTs that a certain user owned. And if the user owned, more than 10 NFTs and we wanted to parse through that information, well, it would take, a large amount of time for that request to come through. So we have to actually loop through and constantly make a request to the blockchain and do these calls, right? These call methods. And so this is very bad user experience, because if you come to the dApp and you want to refresh your NFTs and it takes, anywhere from 3 to 10 seconds to load, well, it's a bad user experience, right? And it really doesn't help the application. And so instead, what the graph aims to do is solve this by adding an additional layer. And this layer is an indexing protocol layer where users of their dApp and designers of the dApp can still interface with the blockchain by writing information to the blockchain, Ethereum or Arbitrum, or even like Arweave, IPFS, whatever kind of like decentralized protocol that we support. And then the actual data is read in by indexers and then indexed onto the graph network, the decentralized network. And this provides an entire different layer with a easy to use GraphQL interface that you can parse the information, and you can do very unique queries by using GraphQL to get that data that you need. And you can also customize these subgraphs, which we'll get to in a second. And so what we're left with is something like this, which is a much better experience for if you are a developer. Anyone who is a front-end developer sees this, they know this is a kind of like a custom GraphQL query. And it's very like custom, where you can kind of decide that the data that you want to query against the database. And you do so by specifically asking for certain keys and getting that data back in an object that is easy for your application to parse. And you can get large amounts of data in one request, as opposed to having to make multiple requests over the same endpoint. And so this is where the graph comes in. So I'm going to talk about the graph a little bit more. The main point of the graph is to provide an API for the true decentralized future of Web3. And that is by providing this index protocol layer for querying various networks and things like IPFS to be able to provide that data layer so that you don't have to rely on the blockchain and the existing like gRPC connections that you would normally have to make to get that data or looping for that data. And so the graph right now is serving anywhere between 1 to 2 billion queries per day on a number of networks. So it's very widely adopted and used. And the graph is a truly decentralized indexing network and protocol, in the sense that the indexers are all in their own decentralized way. Anyone can become an indexer, and anyone can contribute to the network in that way as well. So this is I think this slide's a little out of date. It's actually over, I think, 350 indexers worldwide. And these are indexers that are owned by individuals, and this data is being indexed on their nodes. And there is no, corporation or like the Edge node or the Graph Foundation is not holding onto this data. This data is literally for the network, and it's all redundant. It's a fast, cheap, and reliable way to get blockchain data. And really the goal is to create, again, this global open API for decentralized data. And in the end, that's what we all want to accomplish, right? We want to build truly decentralized apps that follow the principles that Web3 aims to follow. And so, what is a subgraph? So we talked a little bit about the graph and kind of this idea of like indexing events or indexing data about the blockchain, right? And this is done through what's called a subgraph, okay? And you can think of a subgraph as really just a organized way to organize your data in a structured way on the graph. This is done by a couple different configuration files, and we're going to walk through those in a little bit. But essentially, you have a number of configuration files. You have a schema that you define with entities of your data, and then that data is stored in that easy to understand way. And we can think of it as like this. We have all these different protocols that are being built on, let's just say, Ethereum for this case. And there's a lot of noise, right, on the blockchain. There's a lot of going back between different kinds of data. And there's lots of protocols being built every day. I mean, there's a new dApp that gets launched every week, every day. And so it starts to become kind of a little bit of a mess to keep track of all this data. And so what subgraphs do is they allow developers and dApp owners and dApp teams to build a specified subgraph that allows you to organize your data in an easy to consume way. So if you're building a dApp that is somehow interacting with Uniswap, or if you're building a dApp that somehow is interacting with Aave or Foundation or Zora or any of these MakerDAO, there are subgraphs that have already been created by these developers that make it easy for you to consume and just grab that API data as well. So you can make use of an existing subgraph, or if you're building a dApp and building in your own smart contract, then you can build a subgraph for that as well. And so this is kind of what the architecture looks like. You configure that on the top, you have your dApp, right? This is like your front end. This is where you're deploying your front end application, right? And you normally have to, do transactions to be able to write to the blockchain. So we can see here that we're doing transactions to the smart contract. And then that smart contract, essentially, you write events, right? So if you're familiar with Solidity or Viper, there's a little bit of echo, by the way. I don't know if you're on mute. If you're familiar with smart contracts and events, you essentially emit an event as like a cheap way to log data, right? And this allows you to update your UI usually to like what's going on, and then also create that kind of like history of what's going on with transactions. So you might event like for an NFT, you might have a to and a from, and then the actual NFT ID, right? To keep track of where it was transferred to. But what happens with the graph is the graph node picks up these events, and they're essentially run through what's called a mapping or a WASM module. And they're basically transformed in this nice, pretty way in these entities in the schema. And that allows you to build essentially a table for different parts of your events and store them on the graph node. And then instead of having to query, again, the blockchain itself, we just can do a query against the GraphQL API, and we can get that data in our smart contract that has been emitted on the blockchain. And this is a very optimized way to build an application. Anyone that knows front-end development knows that like GraphQL is just the most optimized way to do that. And so here's what we see, and this is just a fun little GIF of live footage of what subgraphs actually do. We have this huge mess of data going across the blockchain, and subgraphs help us organize that data in an easy to way fashion. And I still want to know how this is done. This is really cool. I could stare at this for hours. But yeah, that's the kind of overall goal for subgraphs. If you're interested in joining the graph ecosystem, I would scan this if you guys are listening and you're interested in kind of being part of the community. There's lots of different ways you can get involved. There's the Graph Advocates program. There is the subgraph community where you can actually build subgraphs. There's tons of information online. We're hiring as well for jobs all the time. And yeah, there's ways that you can network and get involved in the graph ecosystem. And it's a really, really good community of really, really bright individuals that really want to move Web3 forward. So now it's time to build. Let's kind of get started. I'm going to bring up my other browser here. Anyone who has seen me on some previous videos on Growick or maybe on YouTube, I'm a huge fan of Scaffold ETH. I'm a Scaffold ETH advocate. But for today, we're just going to start really simple. A lot of developers use Remix. Remix is this kind of web-based UI that you can like kind of really easily build a smart contract inside your web UI and then deploy it out. So we're going to use that. So when you go to Remix and you remix.ethereum.org, you'll have this option where you have like a default workspace where you can kind of get started with like this kind of bare bones contract. But we also have this workspace where you can create one and choose from a template. So we're going to choose an ERC. We could do an ERC20 or we can do an ERC721. So we're going to do ERC721, which is kind of like the most basic NFT that you can create as a smart contract. And then we're going to make it mintable so that we can actually like mint some NFTs in the demo that we're going to be doing. And then we click OK. So we're going to build this and it's going to go out and kind of just build this kind of skeleton, contract that we have. And we can go to our contract here under my token.sol. And it just gives us a smart contract that's ready to go. It's using Pragma Solidity 8.9 or 0.8.9. And then we have like a token. So we could name this token. We'll say it's Miami token. And it will make the symbol MIA. And that's all we'll change. We're just going to add a couple things and then save that. And then we're going to, after we save it, you'll see that it compiled successfully. So we could recompile it just to make sure by clicking this button, but this is kind of like your navigation bar. So we create the contract here, we compile it, it compiled successfully. We got that little green checkbox, and we're using 0.8.18 compiler here. And then we also have this way to deploy it. Now, what's cool about here is we can actually just come here and choose injected MetaMask provider. So we can do that. and it's going to ask me to sign in with MetaMask. So we can do that. And now we can deploy our smart contract to wherever we decide to. So we want to switch to Sepolia. Let's make sure, we're on Sepolia. So I got my Sepolia ETH in this contract. So here it says Sepolia, we're connected to that network through our MetaMask account. If you don't have a MetaMask account, you can just go to metamask.io and you can sign up for one. You'll need some Sepolia ETH, and there's a ton of Sepolia faucets that you can get. If you just do Sepolia faucet, I think it's sepoliafaucet.com actually is like the most popular one. Yeah, here. And it's through Infura, and you can get some play Sepolia ETH so that you could do this demo if you wanted to at home. But I've already gone ahead and did that. So we have some ETH here. So all we need to do is click deploy. It's going to take our NFT, and it's going to pop us up a little pop-up here that says, all right, well, you need to pay the gas for this smart contract. So this smart contract at the current time, the amount of gas is going to cost me $10.15 in Sepolia ETH. So it's not real money, just play money. So we can click that and we're good. So now we're deploying. We can see here that the transaction has kind of initiated. And as soon as it's done, it might take 10 seconds or 15 seconds to do. But as soon as it's done, it's going to pop up a kind of a little dialog here. There it goes, a little checkbox. And then we have this ability to like debug the contract. But if we look down here on the left, we'll see that we have the copy of the contract. So now we have all of the functions that come with an NFT. So we can come here and we'll see that there's this like safe mint option. So if you want to mint an NFT, you need to actually call the function to do that, right? So we have this function that was already built. And that is part of the ERC-721 spec from OpenZeppelin. So it's already listed there. So we can grab our address here. So let's go to MetaMask and get our address, copy it to the clipboard. And then we'll paste it in here and we'll mint token ID 0, which is like the first token, and hit transact. Same thing, it's going to ask us to pop up and verify that. So we can say confirm. And same thing, we just need to wait, right? We're on a test net. So Sepolia is a test net. And it's rather quick and rather widely used. There's a decent amount of validators going. So we should be able to get that. There we go. So now our transaction was successful. And so now we can grab the address of our token here. And let's come over here to the Etherscan, which is a way for you to browse through and see transactions, right? And so let's look up this contract. Let's search it. So we grab the contract and we can see here that we have the deployment. And then we also see that we have our NFT minting. So we have our first deployment, which was done here, the contract creation. And we also have the NFT that was minted right here. And so we can go into the details of that if we wanted to. But if we go here to contract, we'll see something that's interesting. We see all of the bytecode for the contract, but we don't actually have a verified contract. So it's kind of general practice if you're building a smart contract that you should verify it. So we're going to do that. So Remix has a plugin manager where you can like add a plugin. So I've gone ahead and already did that. If you just search Etherscan contract verification plugin through the UI, you can add that. But essentially what it allows us to do is you'll need an API key from Etherscan. So you can go to etherscan.com and get an API key. And then it just allows us to pick a token. So I think the one that we're doing is called My Token. And then we just need to put the address in here and then hit verify. And that will take our contract, essentially, all of our source code. It will send it to Etherscan and it will compare the bytecode that it compiles it as versus what's stored on the actual blockchain and make sure that they match. And so now if we come back here and refresh, we can see, let's see. It hasn't verified. We'll give it 1 second. It might take a sec. We can try to verify it one more time. Contract source code already verified. Okay, so it might take a second. There we go. Okay, so it's a little slow, but here we go to contract, and now we see we have this like green check. So this green check is really just like I said, it's a way for you to open source your contract so that the world can see it, so that they can actually kind of have some trust in your contract, and we can see that it's contract. And the reason why we need that is because when you're building a subgraph, one of the cool features is we use the graph tool to automatically go grab the ABI and build out our subgraph for us. So that's what we're going to do next. So let's go to Subgraph Studio. So when you first log in, let me log out real quick so you guys can see what this looks like. If you go to thegraph.com/studio, the first thing it's going to do is ask you to connect your wallet. Same thing. We want to use MetaMask, right? And we're just going to sign to prove that it's us. If you are first signing up, I think it might ask you to create an account. So you sign that and it'll create you an account on the Graph Studio. And then what we can do is say, create a subgraph, okay? And we can call it, we'll call it Miami, MIA, things like that. And then we have to select the blockchain. So we deployed this to Sepolia, the testnet, and we just added support for the graph to do subgraphs for Sepolia rather recently, I think like a month or so. So we can do create subgraph. Okay, so we have this MIA Miami token, right? And what's cool is it gives you really like everything that you need to do to start getting your subgraph built. So if it's the first time that you've ever started toying around with subgraphs, you want to install the Graph CLI tool. So you can do that by just simply grabbing either Yarn or the npm package and putting that into your terminal. So I've already gone ahead and do that. So what I'm going to do is just make a directory here called Miami. I'm going to go inside there. And then I've already gone ahead and done this. I think we can just do it just to show what it would look like. Let's see if it just tells us if it's already installed. There it is. So it's already successfully installed. So it might have updated the version for me. That's good. So that should be pretty easy. You'll need to either have Yarn or Node.js. Actually, you'll need both installed. So install those. And then we can init the studio. So we can see here, we can do a graph init and pass in the studio name. So we can paste that here. Go ahead and do that. Then it's going to start prompting us. So it's going to ask us, all right, well, what network are we on? So we're on a Ethereum-based network. So we want to choose Ethereum. And we want to name it. We'll just name it Miami MIA. And we can create it in the same directory. And then it's going to ask us what network we deployed to. So we need to find Sepolia, which is kind of all the way here at the bottom because it's a rather new network. Sepolia, and then it's going to ask us for the contract address. So we have that, right? So let's go here. Let's grab the contract address and paste that in. So it went out, it fetched the ABI from Etherscan, and it injected it into the CLI, but then it wants to know the start block. So if you want to find the start block, what you can do is go to your transactions for your smart contract, and you can go all the way to the very first transaction here, and we can grab the block number right here. So we can see the block. So there's been a decent amount of blocks, looks like 3 million blocks, right? So let's do 3,706,632. And then we can name the contract. I think the contract is just called contract, so we can just name it that. And then do we want to index the events as entities? Yes, we do. It's very important, right? That's probably the most important part, is we want to actually grab all of the events, and we want to create these entities. Now I'm going to show you guys what that looks like. So right now it's going out, it's installing any dependencies that need to install, and then it's actually generating the ABI and the schema for you, or it tells you that you need to do that. And then it asks us if we want to add another contract, but we don't. So we're ready to go. So the next thing we need to do is actually authenticate against this subgraph studio, because we need to be able to create a connection essentially between this, the graph, subgraph studio, and our actual CLI. So we're going to do that, and that's going to authenticate us. And then we're going to go into that directory where the token is here, and we're going to do what's called a code gen, and we're going to do a graph build. So this is going to generate all of the code. It's going to generate the schema. It's going to create the subgraph YAML, and then it's going to compile and build the module, the mapping file, which is an assembly script, so that we can start parsing this information, right? So let's load up this inside of a code editor, and let's kind of explore what we've kind of done so far. So the basic overview, or I should say, or the outline of how a subgraph is created, is it's all kind of wraps around this concept of this subgraph.yaml. So this is kind of what holds everything together and tells your subgraph exactly where it needs to go to read the contract, what network you're on. So you can see here we have that it's an Ethereum kind of smart contract, or I should say data type of Ethereum. It's on the Sepolia network. We have the address. We have the start block that we put in, right? We have the name of the ABI, which is very, very important, because that's how we parsed all of the events. We needed to know what the ABI was. So we got the ABI there. And then what's important here is we have this entities, and it's written. These entities are, you can think of them as like handlers, and they're a way for you to like handle the events that are in your smart contract. I'm sorry, event handlers are here. The entities is the actual data structure. So you can think of like, this is an NFT smart contract. So there's 4 different events in our smart contract. There's the approval, which allows us to approve NFTs, approve for anyone to transfer or buy an NFT, the transfership, the actual transferred, ownership transferred, or the actual transfer. So there's these 4 events that are inside of, if we were to look through the source code, we would see those inside the source code. And then we have here, we load the ABI, and this is all generated for you. So you don't really need to understand this, but it is good to kind of wrap your head around. And then we have the event handlers. And this is where we're actually running these kind of operations to store the data as the events happen. So we can go to those and we can see what that looks like. So under source and then under contract.ts. So here we have, this is written in assembly script. It's very similar to TypeScript, but it's a little bit more limited. And we can see here that we have these functions that create the entities, they create these data objects, and then save that data into the schema. And then we have the schema here as well, which allows us to, again, organize how we want our data. So you can think of these as like data objects, right? So more importantly, we're going to focus on the transfer function, or the transfer event, and the transfer entity. This is a keeping track of the ID that of the actual NFT. It's keeping track where it came from, where it was transferred to, the token ID, the block number, the timestamp, and then the transaction hash. So, and you can customize this. Like if you wanted to, you could add, like if you cared about something specific, or you didn't care about something, you could remove it. You just need to update it also inside of your mappings. So these 3 things are kind of like the trifecta of subgraphs. Your subgraph YAML, which kind of, like I said, keeps everything together. Your actual mapping, which tells the indexers how to store your data, right, by using this assembly script that's executed in WASM. And then we have the actual schema, which is actually how the data should be stored. So with those 3 things, then we have our kind of way to store the data. So let's go ahead, now that we've already generated all this stuff, let's go back to the Subgraph Studio and let's do the last step. So after you've created the code and you've built it and you built the WASM module, now you're ready to actually deploy this to the network. And so we're going to deploy this to the Subgraph Studio by just doing a graph deploy -- studio and then reference our studio name like this. So let's type that. And then it's going to ask us what version we want to do. So if you're a developer, as you start building your dApp, you'll kind of iterate on your dApp, right? You'll start creating different versions and you're testing, especially if you're on like a test net. You know, you might start to have different iterations of your smart contract, and so you would then update your versions, right? So we're going to do 0.0.1, which is kind of like the base version, right? And it's going to take all that stuff we generated, and it's going to transfer it and make it available. It's going to upload some of the stuff to IPFS, and it's going to make it available in the Subgraph Studio. And so we can see that it was deployed. And then we also see that we have our endpoint here. So we have our HTTP endpoint. So we can grab that, come over here and paste it in and check it out. All right, so this is where it gets really interesting. So now we have this GraphQL API that essentially is available to us to be able to see the historical information of our smart contract. So we can go to the Explorer, we can go to transfers, we can grab let's grab who it was transferred from, who it was transferred to, and the token ID, right? And then we can hit play, that's it. And then we should get a response back. So we got this data transfer. So here's the data that's in the API request. So it's just a GraphQL response. There's a transfers object essentially. And inside that, there's an array, or not an array, but an object that contains the from. So this is the account creation right here, or I should say it's created from nothing. So it was transferred from no one. So that's why it's all zeros, but it was transferred to my address, which if we look here, it should match. So I'm 0x007, 0x007. And we can come in here now, we can like mint another NFT. So let's go back, let's go to our deployment. And now let's mint one more. Let's grab our address. Let's do a safe mint. Oh, it's already there. And let's do number 1 as well. Transact. Let's sign that transaction. Give it a second. And then what we've basically done is just minted another NFT to my MetaMask wallet. So we'll just give that a second. There it goes, it's successful. And so now we can come back to the contract and just make sure that it's there inside Etherscan, which might take a sec for it to load. There it goes. So now we have these 2 mints that we did. We called safe mint twice. And so now if we go back to our query and hit play again, now we get our second one. So you can see already, like, this is going to be saving on the developer's time because he's not going to have to create a loop to go through and grab each one, right? He's just going to be able to do one simple query to get the data structure that he wants. And it's really cool because it's got this explorer, and then it creates the query for you. And then you have that available out in your output. So then you would just pull this data object into your application and display it in a really easy one API call, and you get all the data that you need. Okay, so that's pretty much my overview. Let's go ahead and stop sharing, and let me go back to the other window, and let's see if you guys have some questions. Okay.
Great. Wow. That was like 30 on the nose. I'm impressed.
Yeah. I was trying to go for 30 and I made it.
Like on the nose. Very good. Whirlwind. So I am a beginning developer, and I know that endpoints are a big pain in the ass when you're at a hackathon and trying to figure out, where am I getting my information? What's going on? How can the graph help you interface with the network to simplify your, stop beating your head against the wall?
Yeah. So the graph kind of fills in this middle area, right? The graph isn't really focused on like the full developer lifecycle. Right. So we're kind of like this tool that you use on top. Now, what I would say to anyone who knows me and followed some of my stuff online, a very good start is to go to what's called Scaffold ETH. And we have a direct integration with Scaffold ETH. And I would recommend that anyone who is kind of building Scaffold ETH is a good start to be able to deploy your contract locally. There's a special, so Scaffold ETH 2, there's a special branch that has subgraph support. So if you go to Scaffold ETH, actually, maybe I should share my screen again, just so that it would just make more sense. So let me share my screen again. Cool, can you see my screen?
Yes.
Awesome. Okay, so if we go to Scaffold ETH 2, and then there's a special branch here. So Scaffold, this is the first version. We need to go to Scaffold ETH 2. So this is the newest version. There's a special branch. So if you're kind of new to building, Scaffold ETH is just a great resource. And there's one in here that is called Subgraph Package, okay? And this one has a complete solution of how you can deploy your application on a local hard hat node. And you can essentially build a smart contract. It comes with a UI, so it comes with a lot of the endpoints connections already set up for you. And then it also comes with all the information to deploy a subgraph. So under packages and under subgraph, there's an entire section on how to create a subgraph on top of that. So it kind of helps with that kind of missing gap. So if you're looking for the full experience of the developer lifecycle of building an app, then you start with Scaffold ETH, you build your smart contract, then you build a subgraph on top of that by utilizing this kind of like special package. Some people like to do Remix, but I think Scaffold is good for beginners because it makes a lot of decisions for you and abstracts a lot of the stuff away that you don't really need to do, so you can focus on building. So hopefully that answers that question.
Yeah, it's jumping into this world is mind blowing. What do you think are the main advantages to, besides speed? Are there ecological advantages? Are there like what are the advantages to using, because I know that the footprint of a blockchain can be huge.
Mhm.
And so to have these middle layers, does it help on the ecological front?
I wouldn't really say on the ecological front. It's just more of a way for I would say more on like coordination, right?
Mhm.
It allows developers to kind of like come together and like create these special data structures to coordinate better. And so what we're seeing is that there's a lot of dApp builders that are kind of working together, or there's other protocols that are helping to improve even existing subgraphs. So I think that something like the graph helps kind of with that coordination. And then there's a lot of innovation happening in the graph as well. There's some really cool stuff called substreams that's coming out, which is quite interesting to be able to speed up the network even more to where it is now. And so really, I think it's just we kind of help bring all of the protocols together, right?
Okay.
And that's it. I think that's kind of what we're focused on, right?
Right. Because there are so many that you need to coordinate them. It's to have the overview. Can you give me sort of an overview, like of the, how am I explaining this? So an overview of, you've got all of these different protocols, and the graph, what sits in the middle and speaks to all of them.
So the graph is a decentralized network. So you can think of it as, we have like all of these people that are running on the Ethereum network. They're running validators, right?
Right.
Well, on the graph network, we have all of these individuals running indexers, and so what they are doing is they're connected on the decentralized network, and they're all basically essentially like being signaled on like what kind of data needs to be picked up and what kind of data needs to be served. And so you can kind of think of it as this like decentralized data, tool or data layer that kind of sits above, right, all of the blockchains, right, and really just provides that extra layer to be able to get the data in an easy to consume way, in a cheap way, that is more kind of in line with, again, the coordinated way that blockchain is trying to run. Yeah.
And so by cheap way, you mean gas fees?
No, so I mean there is.
No?
So if you want to deploy a smart contract on Ethereum, you pay the fee to deploy the blockchain, deploy it on the blockchain with gas. But the data, data for reading from the blockchain is free, right? So there's no need to, but it's slow, right? So the way that the graph works is all these indexers are coming together and building. People are building subgraphs inside of the actual network and deploying those. And these indexers are picking up subgraphs that are important, and you do that by what's called signaling. You can signal to the network and say, hey, this subgraph's important. You can pay some GRT, and you can get it staked onto the network. And all these indexers pick it up, and then the dApps pay to read the data from the graph, as opposed to having to do this slow method of like doing these RPC calls. Instead, they can just query the network, through there. And so if we look at like, if you were to set up your own indexer in your own way, and you were to put it on like Google Cloud or AWS or some kind of like Web 2 style infrastructure, it's very expensive to run, because you have to have a server, you have to have replication, you got to have load balancing, you got to pay, you got to maintain it, you have to have an SRE that's managing everything and keeping the uptime. And what the graph provides is just this decentralized way that people are building it in that way, and all they need to do is pay the GRT, and it's upwards of hundreds of times cheaper than having to run your own infrastructure and keeping that data in another way, right? And so we're just kind of this way to elevate that blockchain data.
That's fantastic. Yeah, so it's sort of like a Dewey Decimal System, almost.
Yeah, the Dewey Decimal System of Web3. I like that.
Of Web3.
We often say like the Google of Web3, right? But I like the Dewey Decimal System. I'm going to start using that.
Yeah. Sounds like it makes it just so much easier and quicker and cheaper, like you said. And I don't know what else to ask you. What would you like people to know?
Well,
like, what do you see?
Yeah, go ahead. What were you saying?
Well, what do you see the graph helping people, like in real world terms? accomplish?
Yeah, I mean, it definitely, I think in real world terms, there's a lot of cool stuff that Edge and Node and some, there's a browser called Geo. I don't know if you've heard of Geo, but it's kind of like a spin-off at Edge and Node that Yaniv created. And it's this kind of, it utilizes subgraphs, and it's a kind of a way to coordinate and bring people together using verifiable data that is stored on the blockchain, and kind of like store that information and coordinate in a way. So I would highly recommend people check that out if you're interested. It's called Geo Browser. You can just go to Geo Browser. I think geobrowser.io. So Geo Browser. Yeah, geobrowser.io. And then you can actually launch GeoGenesis, which GeoGenesis is this kind of like DApp. It's essentially a DApp, and it uses subgraphs, and it has all sorts of information like about crypto, about AI, and we're starting to build that up as like a source of truth. So one example is we have a section on San Francisco and how we're trying to improve San Francisco because there's some issues with homelessness and crime. And so people are coming together by creating these spaces where we can like discuss these information. And so that's really, really cool, right? And it's all using all decentralized data, right? And people can contribute to that. So that's one way I just, it's kind of a fun little thing.
No, that's fascinating. So how like for homelessness, what would people go on and do? Would they report, hey, there's a food kitchen over here, there's a, et cetera. There seems to be a lot of congestion over here. What would you do?
Yeah, I mean, it could be something like that. It could be, hey, like, coordinating on ideas on how we can improve the city, how we can make things, better for, certain areas. Really just, again, I go back to coordination, and I think that coordination is such a huge part of like blockchain and Web3. And, that's really what it aims to do, is bring people together to try to work on things, right? We're so separated these days when it comes to, working on the internet, working from home, COVID, and all this stuff, and so I think like Geo Browser is this cool idea, again, using subgraphs to bring people back together. And this is kind of like we're doing this, there's a lot of topics on there, but the San Francisco stuff is mainly San Francisco. But if, this is something that works and we're able to actually coordinate using Geo Browser, I think it's really cool. And we can take that and take it out. Yeah.
I think another idea would be, I live in Miami, obviously. I live in Coconut Grove, and, we're working on, disaster resilience, because we're sort of the leading edge of climate as far as flooding and hurricanes. And I see a really good opportunity for decentralized communication. One part is down, how are you going to coordinate disaster relief? I think there are just a lot of opportunities to use this. And the more we decentralize, the more redundancy we have, I think the better off we are.
Yeah, I agree. Definitely.
Fantastic. Is there anything else that you would like us to know?
No, I mean, I would highly recommend anyone that, is interested in learning more about the graph, just go to thegraph.com. There's also tons of other videos that have, on YouTube about the graph that will kind of get you up to speed. We also have documentation, really good documentation on how to build a subgraph. If you're somewhat technical and you want to get more involved in the community, there's the Graph Advocates Program, which is a group of decentralized builders that are building on the graph. We also have what's called the Graph Builders DAO and the Graph Builders office hours that we're going to be doing. So if you start building subgraphs and you get lost, we have this like weekly kind of call where we might demo like some way that the graph integrates, with XYZ, or like how you actually use some of our tooling, and you can come there and ask questions. So I'd highly recommend looking at the Graph Discord for that. The Graph Discord is very, very vibrant. There's actually two. There's the Graph Advocates Discord, and then there's the Graph Protocol Discord. Both are really good places to be if you want to learn more and just get involved in the community.
That's fantastic. It sounds like you have a lot of support for your community.
Yes, the graph community is just amazing. I've been in a lot of communities. The Build Guild or the Biddle Guild is one of my favorites, but also the graph community is just amazing. And, everyone's the stuff that we're working on and, you know, contributing to the ecosystem, I think is just, you know, amazing and next level. And I think it's going to help really propel Web3. And, you know, things like the Geo browser is really, really cool. And it's this thing that we're trying to bring to, you know, bring to the world in a good way. So yeah, there's a lot of cool stuff and a lot of good support. And I would love for anyone who's listening to get involved.
Wonderful. And I'm certainly going to go check it out. I'm intrigued.
Yeah. And I will see you guys at ETH Miami. I'm looking forward to that.
Yay.
In the sun.
See you then. Yes, we're going to have fun.
Thank you, guys.
Thank you.